Hi everyone, welcome our presentation. Our project subject is to detect outliers with machine learning. Within the scope of this project, outlier detection was made using artificial neural network, which is one of the machine learning techniques and GNA climate dataset. We used RNN and LSTM model in this project, and we examined their performance.
And then we have some important pros for our project. These are deep learning, machine learning, long short-term memory, LSTM, the current neural network, RNN, and outlier.
We will start with deep learning to explain these concepts. Deep learning is a machine learning method consisting of multiple layers that predicts results with a given data set. Actually, we can say deep learning is a sub-branch of machine learning, while machine learning is a sub-branch of artificial intelligence.
Second one, machine learning. Machine learning is the study of computer algorithms that improve automatically through experience and by the use of data.
Other important concepts is long short-term memory. Long short-term memory, LSTM, is a recurrent neural network architecture that remembers values at random intervals. Stored values are not changed when learned progress is made in LSTM. Actually, LSTM is very suitable for classifying and processing time series and time series analysis.
And then recurrent neural network, RNN. Recurrent neural networks are a class of artificial neural networks in which the connections between nodes form a directed loop. RNN, unlike feed-forward neural networks, RNN can use their input memory to process arbitrary sequences of inputs. The main purpose of RNN is to use sequential information.
The other concept is outlier. Outlier data is basically colored data that differs from other data in the data set according to the examined features.
You can see our libraries for our project. The libraries in this table are the necessary libraries for our project. We need to import these libraries for success project. Science various calculations and visualizations are used in the time series analysis. Various libraries are used to perform the necessary pre-processing and analyze our data.
Read data. In this part, we show data we read in a table and made changes in the column names in order to better understand our data. You can see our data set in this table.
We have a big and crowded data set. We need to drop, we will not use for analyze features with the drop command. You can see this code and you can see last table after drop.
Data pre-processing. In this part, we made a pre-processing to make our data suitable for analysis. First, we divided our dataset into train and test. We allocate 99.5% of the dataset we use as train data, and the other data is test data. After this, we carried out the standardization process. After this, we set a time steps. The purpose of this value is to train as many rows as the value. We have determined and to predict the next row according to these rows.
And then we will talk about model setup. After performing the necessary pre-processing, we moved on the stage of building our model. This example of an LSTM model. We talk about some important things in this model. We choose the mean absolute error for a loss function, and then a repeat vector input in our model provides repetition, and the time distribute layer creates a vector as long as the number of outputs from the previous layer. After successfully running our model, and then we fit our model.
You can see fit codes in right side. This fit code has some important things like epoch, validation split, and bit size. If we talk about the concepts here, let's start with epoch. While the model is being trained, not all of the data is included in the training at the same time. They take part in education in a certain number of parts. The first piece is trained. The performance of the model is tested. The performance of the model increases noticeably as the number of epoch increases. The other important concept is validation split. Validation split is a function that splits the data.
Loss analysis and visualization. In this part, we visualized our loss and validation loss values that we obtained after running our model. The red line on the graph, the loss from our training data, and the blue line shows our validation loss values, as you can see. And then first graph for mean absolute error on training data, and the second graph mean absolute error on the testing data. We need this graph because if we want to find threshold values, we must use these graphs.
In this part, we set a threshold value and dumped our outliers into a data frame. As you can see, line 1, we set our threshold value to 0.2. Here, if the loss value is greater than threshold, we have taken that data as an outlier. Outliers visualization. Our outliers and all our data are visualized in this graph, as you can see. The graph has a red point and blue line. The red points on the graph represent our outliers values. You can see as you can see. Blue line, the blue line on the graph represents PM bar values and dataset. Thanks for listening.
Yes, thanks for all.